Wassce on deck 2018, question 3. From 2 points P and Q, 50 meters apart, and on the same horizontal line as the foot of a tower, the angle of elevation of the top of the tower are 35 degrees and 45 degrees respectively. If P and Q are on the same side of the tower, A. Represent the information in a diagram. B. Find, correct to the nearest meter, the height of the tower. Alright, this interesting. So now let's start solving. It's not difficult as usual. It's not difficult. Alright. So let's start. So I'm going to show the diagram here. Please don't skip the diagram because that's also going to fetch you marks. So from 2 points P and Q, 50 meters apart. That means that if this is the point P, between the point P and the point Q, let's assume the point Q is here. That's going to be 15 meters. 15 meters apart. And on the same horizontal line as the foot of the tower. So that means that the question is talking about a tower. Whenever you see a tower, assume it to be like a pole. Okay, as what? A pole. So okay, let's continue. The foot of the tower. Now, the angle of elevation of the top of the tower are 35 degrees and 45 degrees respectively. If P and Q are on the same side of the tower, if P and Q are on the same side of the what? Of the tower. So it's going to go like this. Now, the question is saying that both P and Q are on the same side of the what? The tower. So, let's assume, because of the space, let me reduce this one. So, the P and Q is here 15 meters long, alright, or apart. Then, let's assume that the tower that is the pole is somewhere here. The pole is somewhere here. Don't forget that the question says, if P and Q are on the same side of the tower, so they are all on the same one side. They are all on the same side. Okay, let's continue. So the distance from where the side where the P and the Q is to where the, let's call this one R. Let's assume that this one is R. To where the pole is, we don't know. So this part is a part that we don't know. Alright. So the question says that okay, 50 meters apart, and on the same horizontal line as the foot of the tower, the angle of elevation of the top of the tower are, so the angle of elevation of the top of the what? The tower. That means that you can assume this one to be a human being, this one to be another human being. Like I said, whenever you are reading this type of question, assume yourself in the question. So there is a pole here, and one guy is standing here called P, another guy is standing here called Q. Now, from where the P, the first guy and the second guy is, they are all on one side of the tower. It can be at this side or that side. It doesn't matter. What matters is the angle. There is the angle given that will help you to know whether this one will be close to the tower or this one will be close to the tower. Because I'm sure by now someone is thinking that, okay, why don't we assume that the pole is somewhere here? Why don't we assume that the pole, which is same as the tower, is somewhere here? Now, why is it that I'm not bringing it here? Let me explain it for your understanding. Let's look at the angle of elevation. We have 35 degrees and 45 degrees. So the 35 will go for the P because it's respectively, and the 45 will go for, so I'm coming, let me do that here. So the P angle will be the first one, which is 35 degrees, and the Q angle will be for the second one, which is what? 45 degrees. Now watch. Assume that the first observer is here and the second observer is here, which is called P and Q. And we are to look at an angle of this. Okay? And we are to look at an angle of this. Now, question. The two of us, who is going to observe the larger angle? Who is going to observe the larger angle? You see, if you are to look for, I think I should shift the video to this side so that you can see what I'm trying to. Okay, let me use this side to this side. Will you be able to see? Anyway. Alright, let me show the demonstration here. So now watch. If I'm the first observer and I'm here, and I'm looking at the edge of the building, you see, the more you get close to the building, the larger the angle you will see it. The more you get close to the building, the larger the angle. But if you are far apart, your angle will be too small. Your angle will be what? Too small. That is why if you want to observe something well, you need to get closer. So the closer of the elevation that you go, the larger the angle. So now let's come. I hope you understand what I mean. The side of your angle will determine by how much close you are to the top or to the edge of this building. But if you are far apart, your angle will be too small. Right? The more close you are will determine the way you are going to view the edge of the building. Alright, so let's come to the board. Very good. So now, why is it that the pole or the tower will not be here, but rather here? P is 35 degrees. Q is 45 degrees. So, if the tower is here, then the P angle will be 35 and the Q angle will be what? 45. Which can never be so. Which can never be so for the reason that the larger the angle will determine by how much you are close to the what? To the observer. You see, or to what you are observing. So the P can never take it means that the tower will not be here because the P for the angle is less. So that is why the tower is here. So the angle of elevation of this observer will go like this. And that angle of elevation is 45 degrees. Most students always see elevation depression question to be challenging due to this reason. Because if you present it wrongly, you are going to get it wrong. If you don't present it well, you are going to get it wrong. Alright, and the angle here too will be 35 degrees. So the wider you go, the lesser your angle. The closer you go, the higher your angle. Don't forget. If you bring it here and you go like this, if you go like this, you are sketching something. You are sketching something. Yes, you may get marks, maybe some 1 mark out of let's say 7 marks. But you are sketching something, but it's just body exercise. You are not doing anything. All right. So that's all about representation, and the rest is working. Now, what is the question? Represent the information the information in a diagram. In a diagram, not a Venn diagram. B. Find correct to the nearest meter the height of the tower. The height of the tower. That means that we have to look for the height here. You have to look for the height here. Now, you see, we have two right angle triangles in this. The bigger one is here. The bigger one, let me call this one, let's say P. No, let me call it F. We have two triangles. One of the triangles is triangle PFR. The other is triangle QFR. Okay, but they are all sharing the same height. Whether triangle PFR or QFR, they will all share the same height, but different hypotenuse and the what? And the adjacent. Alright. So here, if you consider only this right angle triangle, you can use only this one to find the height here because two sides are unknown. The same to this one. If you consider the bigger triangle, that is triangle PFR, we don't know the hypotenuse, we don't know the side here, even though you know one angle, even the side we don't know because we only know the side from B to Q, but we don't know that of P to what? R. So that one too is going to be something else. So how are we going to learn it? It's just simple. Let's see. There are sometimes you will be asked to calculate the height of the tower. After that, then the floor or the foot of the tower also. There are sometimes you'll be asked to find that. But it's just simple. Let's go for that. Now, from triangle, let's consider the bigger triangle first. From triangle, okay, from triangle PFR, let's assume that here is X. So, if you are considering the bigger triangle, then this is going to be 15 plus X. That is the foot of it. Okay? Alright. Let's continue. So now, from what we have here, the bigger triangle will be something like this. So here is S plus 15 plus X. Here we don't know, so let's make it, let's say H. Let's call it H. Alright. We know the angle, which is 35 degrees. So which formula will relate the height and the adjacent, which is tan 35 degrees will be equal to the opposite, which is H, over the adjacent, which is 15 plus X. So our only job is to make H this or make the height stand alone. So that would be 15 plus X times tan 35. And we can call this equation 1. Alright, it's just simple. Then we consider from triangle QFR. Triangle QFR. That one too, we are considering the smaller triangle. We are considering the smaller triangle. The smaller triangle, the angle there is 45 degrees, and the height is the same as the h, but the foot or the adjacent to the x. I hope you are following. The adjacent to the x. So to be able to solve this, that one too will take tan 45 degrees equal to hypotenuse over the adjacent. Hypotenuse over the adjacent. I don't want to clean it. Let's to manage. Alright, I hope you're not confused. So now, H will be equal to S tan 45 degrees. And we can call this equation 2. We can call this equation 2. We can call this equation 2. So equation 1, equation 2. Now watch. H is equal to this, H is equal to this. Since the height of the smaller right angle triangle and that of the bigger right angle triangle, they are all the same. It means we can equate equation 1 to equation 2. So I'm clearing this part. Oh, I have cleared off the equation 1. Yeah, I think that is. So now, equation 1 equal to equation 2. So equation 1 is H is equal to, I think that is 15 plus x, I can recall. 15 plus s times 30, the angle is 35. And that will be equal to equation 2, this side of the equation 2. S times 45. So, from here you can see that we are getting rid of the h. So everything here, everything in this equation is in terms of what? X. So we can now find for x. Don't forget, I'll be using this, so let me write. S times 45. That's equation 2. Okay, so now let's solve for s here. So this times this, you get 15 times 35 plus this times this, you get s times 35 equals to s times 45. Okay, so now we are looking for s. So time here, if you read this part, be careful not to rush to point some of these things on calculator for now. Don't rush to point it on calculator because you may approximate it and it may affect your final results. So 15 times 35 will be equal to, we are sending the one in terms of s to the side. So this will give you s times 45 minus s times 35. So 15 times 35 is equal to, let's factor s out. So here will be tan 45 minus tan 35. So to be able to get x, then we divide both sides by the whole of this. Therefore, x will be equal to 15 times 35, the whole of this over time 45 minus time 35. Now you see, looking at this, you are just going to point the whole of this on your calculator, then you approximate the final answer, and that's all. But if you try to do it here, you may, if and only if you maintain it in 4 decimal place to work till you get to the final answer, no problem. Alright. And when you solve this, the value of x is going to give you 35.0385. Alright, so if you want to approximate to a whole number, then it will be 35 meters. Don't forget it's in meters, it's a distance. So it's not an angle. It's a distance. So it's not an angle. Alright. So that is that. Now, if that is the x, we are not looking for the distance from here. We are not looking for the distance from Q to the distance from Q to where the pole is. No, but we are rather looking at the length of, or the distance, or let me say the length of the tower. That is what we have to calculate. We have to calculate to the nearest meter the height of the tower. Since you have to calculate to the nearest meter, be careful to approximate this to a whole number. Let's use the whole of this. So it's always advisable you work in 4 decimal place. So now I can clean this part. Now that we know S, let's go look for H. Okay, let me maintain this side. We know that from equation 2, H is S times 45. So H will be equal to S is what? 35.0385. So S times 45. And when you point this on your calculator, you are going to get the height of the tower. And that will be 35. That will be 35 point 35.0385 meters. Alright, so that's going to be the height. So therefore, you conclude that therefore the height of the tower will be 35 meters. That one you can approximate it that it's going to be 35 meters. So clearly you can see that the distance from the Q to the foot of the tower is the same as the height of the tower. Thank you. Take your time. If you do not get anything, play back the video. It's a video. Anytime you watch it, you will still hear something new. Alright. Thank you. See you in the next video. Bye bye. Please, one more time, subscribe. If you haven't, go back and subscribe and check our other videos. Thank you.